Okay, on part C, we want to write the equation of each horizontal tangent line to the graph of f. And I'm going to need to scroll up. So I just record the function, the original function f of x is 3x to the fifth minus 5x to the third plus 2. And I will use the first derivative information above. Okay, so we want to write the equation for each horizontal tangent line to the graph of f. So we go back to the first derivative that we found in part A, and we found that there were three places where the derivative was equal to 0, at x equals -1, at x equals 0, and at x equals 1. I want you to think for a second about the three different ways that we could have a derivative of 0. We could have a derivative of 0 and it be a relative maximum, it could be a relative minimum, or it could be a stationary point. Now, what we're looking for, though, is just the equation of each horizontal tangent line. And one thing that you should note about each of these horizontal tangent lines is that they are all horizontal lines. And so they all will have a slope of 0, and so the equation of the line will just be y equals whatever the y coordinate of the original function is at that particular point. So really all we need to do for this particular problem is to find the value of the function at x equals -1, x equals 0, and x equals 1. And when we find the y coordinate at that point, the equation of the horizontal tangent line that passes through that point will just be y equals whatever. So at f of x equal f of -1, we're going to plug in -1 into the original function. -1 to the fifth is -1, so we're going to get -3. Then again, -1 to the third is -1 times -5 is +5. Then plus 2 is going to equal 4. And so y equals 4 is the equation of the horizontal tangent line to the graph of f that passes through the point x equals -1 and y equals 4. Plugging in 0 into the original function, it should be apparent that that's just 2. And so the equation of the horizontal tangent line to the graph of f that passes through the point x equals 0 and y equals 2 will just be y equals 2. And f of 1, that will be 3 minus 5, which is -2, plus 2, which is 0. And so the equation of the horizontal tangent line to the graph of f that passes through the point 1, 0 will be y equals 0. And that's really all we have to do for this particular problem here. So that one wasn't difficult, but you do need to understand what's happening. Remember that when you have a horizontal tangent line, that tangent line is horizontal. And the equation of that tangent line will just be y equals whatever the y coordinate of the point that it passes through is. We'll go on to the next video and the next problem in the next video.